Alrighty, see this light here flickering? That's actually charging the battery. It's also got a diode over here, right here in the center of this one. It doesn't let the battery back into the plane here. It should be a ground, but it's not. It's got this energy here coming off of it. And so I'm taking that and putting it into a battery. It's actually charging the battery also. It started at, well, here's the battery. It's charging right now. Soon it'll be down here charging these other guys. It's actually got another charging unit, or charging right here, the blue set. This is ground, and this one over here that's on the wire, that's going to the first set of batteries. It's supposed to be charging those. But I'm just monitoring this and see how well it's working. I've got some breakers down here set up, and turn this one on. That supplies power to this, and hey, lights come on. Imagine that. Now you can see the rest of the shop here. Just running the one light off of it right now. My positive terminal. This terminal here goes to the back of the inverter, and these switch the batteries. They're going to be a really large switch, so I had to use breakers. They're 30 amp, but, well, they're AC breakers. Therefore, the DC pole, it doesn't pop the breaker if it goes over 30 amps. So, it's really nice to know if you're trying to duplicate this. Over there's my ground plane, that big old piece of copper, and got a few other things in the way, but ground is over on that side, positive terminal here. I do need to make something, I need to redo the wiring here, of course, but this is just experimental for right now. Once I get it up, and if you notice, the lights are flickering. It's not capturing it as well as I'd like it to. But it's flickering real close to the frequency of the camera. You can see it glowing a little bit there. Those are actually being ran off of the trigger coil. The trigger coil is the green and brown set here, and it's just a coil of wire with these 600 ohm. Well, there's 6 100 ohm resistors there, and on the positives, or the ground side, this is the ground side, I put the ground, and on the positive side I put the positive. Yeah, color of the wires really doesn't matter. When I first started on this, I was colorblind, but that's since changed. So yeah, it looks kind of cool. But it's running this 12 volt power strip of lights, and those LEDs over there are running too. Actually, they're quite bright. So here's another bridge rectifier. I've got to repair this unit because it just goes to the capacitor here, and it's not going to a charging unit, which it needs to. Every one of these here are charged. This one, these big ones. And I'd like to set it up so that And put another one of these diode transistors, resonant, it's a resonator. It turns on and off really, really freaking quick. So thinking about putting one of these on each of the capacitors and have it dump the energy into the battery sets here. So I'm going to need probably 1, 2, 3, 4 of the 2N3055s to put in there. And I need some more resistors. Now, it's charging the battery. Freaking awesome. Love it. Alright, this is only a 1-pole, actually, it's 4 poles generator. I'm using both north and south poles on this one. This one down here will only be using north poles. Notice there's an N. Yeah, there's an N on that magnet. I had to mark them before I glued them. And it chain stuck to it. But there's 4 of them there, and they're 210 pounds or 205 pounds worth of pole each. And, well, this little one here that I have, right here, is going to be that big. And I need to get, I got the switches and stuff here. I think I'm going to go with this design here. This design has been quite powerful. So this is actually 2 coils. The red coil, north is on the top, south is on the bottom, depending on which way you pulse it through the coil. This one here causes a vortex of, and the electrical field is only right there. That's only where the field begins. All of this out here, the field does not grow or build up on the outsides. It only builds up right there inside. It makes it's kind of like a magnifying glass for a magnetic field. Instead of light, you're using compressing the magnetic wave or expanding it, whichever way you want to look at it. But hopefully that's going to be running 1/4 the speed of this guy, but the same frequency. Since I've only got a pancake type motor in here, this in here is going to be much, much better. Still a work in progress, but at least I'm getting some productivity out of it. This battery was right at 1120 when I first started. And let me measure this thing right quick. What does this say? Well, helps I turned it on. And turned it to DC instead of AC. Now it's at 1193. Come on. Good connection. Yeah. 1193. So it's climbing. Alrighty, folks. Kind of a big picture of it. Hopefully I'll have all of this generating more electricity than I know what to do with soon. So, but the preliminary tests are quite interesting. So, yeah, you're seeing a little bit of a flicker, but nothing like what it really looks like. It's almost in phase with the shutter speed on this digital camera. So every time you hear a click, that's actually an on. Actually, it's an off compared to the lights. They're on yeah, they're out of phase 180 degrees.